So I'm Wyatt Allen. I'm here to present Surveyor 2. It's our DSL for surveys, for describing surveys, with tools for running surveys, and finally for analyzing surveys. So let's get started. What is a survey and why surveys? Surveys are something we should all be familiar with, at least conceptually. Maybe we take them online or over the phone. But I think the important point to remember is that surveys are a tool for statistical analysis. There's really no point to a survey if you don't analyze it in the end. And so what have we got? A survey is a set of questions. That might be the simplest way to put it. But put differently, it's a specification of data to collect. And once again, it facilitates statistical analysis. That's its reason to exist. And so it makes a lot of sense to use a computer to make a survey for a variety of reasons. And so we can think of what we would like to see from a computer survey system. We'd like to be able to describe those questions in a DSL that's compositional. And since we're describing data in the first place, of course we'd like to carry type information. We like that. And once again, analysis being so important, why not bake that right into the language? The thing is, a lot of languages, or a lot of computer survey tools, aren't any of these things in the what we want box. They aren't what we want. In this case, here's actually a screenshot from the references section of the paper. These are actually two DSLs, which are not these things. And many other survey systems also don't match up with these things that we would like to see. Well, what does is Surveyor, and so that's what I'll present to you. Surveyor is what we want. So here's an overview of the tour. I'll take you through Surveyor. We'll look at how to write surveys using Surveyor and how to compose surveys. And we'll also look at how surveys have types and composition of surveys results in the composition of those types. And so we'll look at some of the ways in which we can run surveys using Surveyor. And then after we've done that, we've got data, we can analyze the survey data and look how even we can even compose analyses in interesting and exciting ways. And then we'll look at finally some of the Haskell features we use to build it. So writing surveys. We can imagine two very simple surveys, probably the simplest size of survey, the smallest surveys possible would ask one question. In these cases, these would be the types for surveys asking for the respondent's name and age. And you can see the type signature uses string and int. You can already tell that this parameterized data type. And this makes sense. These would be the parameters, the result of this survey. To build surveys, to match this type, we can use the respond constructor. So in this case, given a prompt to display for the question, and a function which is able to process the response from a string to some data type that we're targeting, we create a survey of that data type. So to use this, we can trivially make those two surveys. In the first case, since the target is a string, int is an appropriate processing function. No processing needs to take place. And when we're targeting integer, you can see we use read, which in practice you might not use read because it's vulnerable to some runtime exceptions. And so you might use something more robust in practice. But the point is, this works, and we're all familiar with that function. So now we can look at how we can compose surveys together using this composition operator. So as you can see, given a survey of type B and C, the result is a survey of that pair. So already we can compose those two tiny surveys in this one. But we can also build different types of questions. We can think of the questions built with the respond constructor as a sort of free response question, and in this case as a multiple choice type question. And you can see the constructor is choose in this case. And like before, we use a prompt, in this case rating, and you can see this other expression is a set of options. And so the type for choice, or for choose, you can see the result type of the survey, this A here, is determined by the A of whatever is passed as that choice argument. So this looks pretty useful. Let's see how we can build values of type choice A. So here's that sample replicated below. And above you can see the start of a data type for the choice. You can already see it's sort of the get syntax in Haskell, and I'll progressively reveal the constructor, so that's not the entire thing yet. But the item constructor here takes a prompt and some value associated with that prompt, or with that tag, and that becomes a single option in the multiple choice question. We can compose them together using these two choice composition operators. The first one here with one pipe takes two choices of the same type, and the result is that same type, which makes sense. If either option is chosen, well then either way the result will be of type A. But if there are different types, then it also makes sense that the result will be of type either one or the other. And in that case, we use the double pipe operator. It almost actually accidentally rhymes. We use one pipe for one type and two pipes for two types. So let's look at, well, there's also one more constructor that we'll look at in a minute. But let's look at an example of how to compose types together. So in this case, we have these two data types for different color spaces, the ends of different color spaces. And if we ask the respondent for their favorite color, well, we can list all of them together. The first few are RGB, the last few are CYMK. Those options can only be fused together because we use the double pipe operator here. And to the user, to the respondent, that is, it's just a list. So that's handy. We can also, having given these typed synonyms to clean things up a little bit, create one other type of multiple choice question. So in this case, asking the respondent if they have any dietary restrictions. This might be something that you ask before going to a conference like this. Well, if the respondent says no and selects the no option, well then that's the end of the question. But if they say yes, then we're able to attach a conditional survey to this and only present it in the case that option is selected. So you can see here, here's the last constructor for the choice data type. And given a choice of type B in a survey, not a choice but a survey of type C, is able to create that pair. It makes sense because both that value will have been selected from the item and that results of that survey will be present in such a pair. We also provide some helpers which sort of abstract away a lot of the patterns we might find ourselves writing in building surveys. And these are, we're able to make use of the abstractions provided in Haskell to do these. For instance, we might frequently ask questions that seek text answers, and text works here so we don't have to reuse ID all the time. We're creating items for values which have a show implementation where the show is appropriate as the tag. We can use show item and fold them, in this case, if we have a list of them. And that's nice and handy to create the set of options. We can take that one step further and, using this operator, create a multiple choice question from a list and the prompt. And it looks nice and clean. We generate, in this case, we generate a set of times using a list comprehension from Haskell, which we can create a list any way we like, but we use it right here to build the question. The point, I guess, of this slide is that you can use any of the number of really nice ways to build lists in Haskell to build this question. We'll also provide reusable surveys, and you can write some of your own. In this case, we might frequently ask for a respondent's name, and all that's needed is to just insert this small survey somewhere in your larger survey, and we provide a number of these actually. Additionally, we can create parameterized surveys. This makes sense too. So if we create a data type for the Likert scale, it makes sense for Likert to be a parameterized survey, given some prompt or some statement with which the respondent can either agree or disagree. Then it creates a multiple choice question for them to select some point along the scale. You might ask, Haskell is great, and most of them will agree, I'm sure. All right, so we've looked at some of the ways to build surveys in Surveyor. Here's some of the ways that we can turn it into an actual survey people can respond to and get us data in the end. So in the simplest case, here's a run survey function, which takes a survey of type A and converts it into an IO command of type A. And this is really a command line interface where we're able to interact with the survey on the terminal. So I'll show a quick video of this in use. Calling run survey with the person survey we saw before, it presents the prompts and enables typing an answer. They're collected into the result of the survey. Using the diet, this is an example of a multiple choice question. Since I just selected the first option, that was the N. In this case, since I selected yes, it's able to ask the conditional question in that case. And finally, I can compose surveys on the fly as I pass them into this function. That's very useful for testing things out, for building a survey bit by bit. It's helpful to be able to just try out little bits as you go. But you also might be thinking that you don't like to use text interfaces, and you don't know many people who do. So we thought of that, and we also provide a web interface, which works in much the same way. That's too far. So in this case, using a run server function, but once again passing that composed survey in as argument, all it does is it creates an actual web application. So in this case, I navigate there, and I'm able to fill the survey in the same way I would within the HTML form. In this case, since I selected yes, the conditional question is presented on the next page. And this is really satisfying too, because we're able to create a web application based on a simple Haskell expression. So now we know how to build surveys and we know how to run them, turning them into actual respondent data. Let's look at how we can analyze that data, which was our ultimate goal anyway. So imagine we're in this scenario. We have the info data type and a survey which asks for the appropriate questions to fill that in, and we've got a pile of results. You can think of the simplest way to do analysis on this. What's the simplest question you can have about it? It might be, how many results are there? How many respondents do we have? Well, you can obviously do that with Haskell, since it's a list, using the length function, but we think of this as a zero-dimensional analysis, in the sense that it doesn't look into any of the interesting little bits of the survey answer data type, it just counts them. But a one-dimensional analysis, by that token, would look at just one part of it. So in this case, this is a distribution of how the Likert scale answers might be answered within all of the people who responded to the survey. You can just take a look at it and see, oh, well, most people are agreeing. It's easy to make a statistical inference from that. And in Surveyor, this sort of analysis is a value, and its type is distribution of A, B. And the idea with A and B is that it's a distribution of how values of type B are distributed inside of values of type A, A being the type of the survey. So in this case, since we're looking at Likert answers inside of the survey of type info, this distribution would be typed like this. So with Surveyor, we can build these quite naturally. Using this collate function, we're when provided with a function which is able to extract the interesting value out of a survey answer, encapsulated in a maybe, and given a bunch of answers, it's able to produce the distribution that we want. But the question here, the difficulty here, this isn't the whole story, because that's kind of a difficult thing to write. Well, with Surveyor, we can use guided by to produce that quite easily as well. So with guided by, it's given the survey that we're analyzing in the first place, and using information from that and called in a queried fashion. So for example, guided by the survey produces that A to maybe B that we're interested in. This is a generic function, so the B that is used is determined by the type notation. It's a type-directed extractor. It makes sense also for that to be enclosed in a maybe, because the type we're interested in might not be in the survey at all, or it might be in a conditional part of the survey which wasn't taken in some particular answer. So putting these together, it's really quite trivial, and it almost reads like English. When you say, guided by the survey, please collate the results, and that creates the distribution that we're looking for. We can compose these together, and thinking of, since those were one-dimensional analyses, a two-dimensional analysis would be the composition of two one-dimensional analyses. So this might take the form of cross-tabulation. And you can see here, with the Likert answers, which we were looking at before, on the vertical axis and horizontally with the age responses, we can make statistical inferences, say for instance, that most of the 30-year-olds agree with whatever the statement was. So produce a table like this is also quite simple. If we can make use of the crosstab function, of course, to produce a cross tabulation. And this is taking two distributions. If we create an H distribution in exactly the same way that we created a Likert distribution, pass those together, and it creates the table. You can see also the distributions have to come from the same survey, but be interested in potentially two different types. And so finally, let's look at some of the ways that we use Haskell features to implement Surveyor. We made sort of enthusiastic use of gadgets. The development floundered a little bit until it became quite clear that gadgets were the direction we needed to take. And you've seen how we were able to use the gadgets to compose types together in terms of the way that a survey is constructed. So that's really great. Also, for the generic programming that's used in the analyses, we were able to use some of the facilities associated with Scratchy boilerplate library in Haskell. In this case, these two functions especially. This is only a small section of the code used for guided by, but it illustrates how the maybe semantics allow failures and successes to percolate through the algorithm. It's able to traverse, it creates a traversal based on how it looks at the survey that is being analyzed. So in conclusion, well, yes, Surveyor is what we want. It's a compositional DSL. It's strongly typed. It's platform independent. We can run it in several different ways. And it's written in Haskell, which is just wonderful. And it also does the analysis. Thank you.